We're solving problem 25 from the 2024 AMC 12A. Graph is symmetric about a line if the graph remains unchanged after reflection in that line. For how many quadruples of integers a, b, c, and d, where the absolute value of a, b, c, and d is less than or equal to 5, and c and d are not both 0, is the graph of y equals ax plus b over cx plus d symmetric about the line y over x. So we see for this equation here, what has to be true is that, we know this, that we can have an f of x as equal to an x. So then we can simplify that into this form. So this would be ax plus b over cx plus d over ax plus b over cx plus d and plus b here is equal to x. Now once you multiply everything out, you get that this is x squared ac plus cd plus x times d squared minus a squared minus ab plus bd is equal to 0. Now we have three conditions. So we know that ac plus cd has to be equal to 0. This yields that either a is negative d or c is equal to 0. Then we get that d squared minus a squared is 0. Once again, we get that a is equal to negative d, or just it's one of these two, or you're going to be equal to, or a equals d. And then finally, we have this one. AB plus BD is 0. This gets us A is negative D, or B is 0. So we see for all these three equations, A equals negative D holds true. So therefore, we have 3 of these. So that means we have at least 11 cubed 1, 3, 3, 1 conditions. If we have, so this is the total amount. We can, now we want to subtract more because we might have missed some cases. So if C is not equal to 0, D is equal to 0, and A negative D, this yields us 10 cases we add to this. However, now we'd like to subtract the cases. So what we do is we get the equation x times AC plus CD plus BC plus D squared is 0. We then get, again, two conditions. AC plus CD is 0, and BC plus D squared is 0. And then we get that from here, if C is D is 0, well, we have to subtract 11 cases because we overcounted for this. If C is 0 and D is not 0, well, then we don't subtract any cases. So we're good on this one. However, if C is not equal to 0, yet D is 0, then that means A has to be 0 and B also has to be 0. We subtract 10 cases. Now, if we have C is not equal to 0, D is 0, A equals negative D, and D squared is negative BC, then we have absolute value of D can be 1, 3, 4, 5. In this set of values, we have 2. So 2 ways, and then if the absolute value of d is just 2, then we have 6. So then, counting all these, the total amount we need to subtract here is, this means 2 for every number. So this would be 2 times 2 plus 6 plus 2 plus 2, which is going to be 28. So then, 13, 31, we add the 10 from before, from here, and then subtract the 11, and then subtract this 10, and then subtract this 28. The 10s cancel. Gives us our answer of 1292. And we are done.